Hi, my name is Scott Simpson, and today we'll be talking about pKa and acid strength. So pKa is a number that's associated with acid strength that's used quite a bit in general chemistry, organic chemistry, and analytical chemistry. So we all know what pH is. pH is equal to the negative log of the hydroxide ion concentration. So therefore, if we're thinking about pKa, what this P means is it's a negative log function. So in this case, it would be the negative log of our Ka value. Okay, so now what we want to do is we want to find a relationship between pKa and acid strength. So let's ask the question, if we have two monoprotic acids, there are two monoprotic acids. And the first one has a Ka of 1.0 times 10 to the minus 7, and another with a Ka of 2.5 times 10 to the minus 4. We're going to ask two questions. First question, which acid is stronger? Which acid is stronger? And question B, which has a larger pKa? So ask those two questions. So first thing that we want to answer is which is stronger, and what is meant by acid strength? Acid strength is talking about the ability to dissociate. So let's consider a generic reaction with a monoprotic acid. So we have HA, it's an equilibrium. We get H plus and A minus. If we write out the equilibrium constant expression for this, the Ka, the acid dissociation constant, we get H plus. Remember, it's always products over reactants, A minus over HA. Okay, so now, if we're considering the Ka value, if it's larger, meaning it's getting bigger, the numerator has to be getting bigger than the denominator, meaning that this side of the equation is favored. So therefore, it's dissociating more readily. So if Ka is larger, it is a stronger acid. So comparing our Ka values, we have Ka is equal to 1.0 times 10 to the minus 7, and then we have Ka is equal to 2.5 times 10 to the minus 4. We want to compare those values and see which one's larger, which one's smaller. So, of course, the one on the right is larger. Therefore, this is the stronger acid. Okay, so we've answered part A, which is a stronger acid. The one with the larger Ka value is stronger. But now let's ask the question, which has a larger pKa value? So to do this, we have to look at those Ka values. We have to remind ourselves what pKa is defined as. So pKa is equal to the negative log of Ka. So we have to do this function to both of our Ka values. So if we take pKa negative log 1.0 times 10 to the minus 7, kind of neat thing with this function, if you have a 1 here, all you have to do is take the negative of this exponent, and that will be your answer. And remember, sig figs with logarithmic functions, whatever you're taking the log of, that's how many decimals it should have after the fact. So now if we look at the pKa of negative log 2.5 times 10 to the minus 4. Since this is a little bit larger than 1, it's going to result in a pKa value that's a little bit smaller. We get 3.60. So the species with a Ka of 1.0 times 10 to the minus 7 has a larger pKa value. So mathematically, we've proven a relationship. What is the relationship between pKa and acid strength? As pKa increases, the acid strength goes down, it gets weaker. pKa increases, acid strength decreases. And this is an important point to consider when looking at different species. This is a common question that comes up throughout general chemistry, organic chemistry, analytical chemistry, and even biochemistry, especially when considering the zwitterionic species. Okay, with that, I would like to leave you, if you have any questions or any comments, please leave them below or feel free to contact me. Thank you.